If log base b of x is 0.33 and log base b of z is 0.83, evaluate the following expression. Part A, log base b of z to the power of 4. We apply the power rule. 4 as a coefficient multiplied by log base b of z. Next, we replace the value of log base b of z by the value 0.83. Simplify the number, we get 3.32 as a result. Next example, log base b of the cube root of x divided by z. First of all, we apply the quotient rule. We get log base b of the cube root of x minus log base b of z. Next, apply the power rule for the first term. The cube root of x is the same as x to the power 1/3. So 1/3 log base b of x minus log base b of z equals 1/3 multiplied by the quantity that represents log base b of x, or 0.33, minus the quantity that represents the value of log base b of z, or 0.83. We will get negative 0.72 as a result. Sorry. Next, find the domain of the following function. Natural log function will be defined where the expression greater than 0. Therefore, we're going to set up 9 minus x greater than 0. We get x is less than 9. The domain of this function is the set of x such that x is less than 9, or writing in the interval notation as negative infinity until 9. Next example, natural log of x squared minus 3x minus 4. We set up the expression x squared minus 3x minus 4 less than 0, and then factor completely to obtain x minus 4 times x plus 1, strictly less than 0. X will be 0 at 4, for x equals negative 1. Draw the real number line at negative 1 at 4 and analyze the plus minus sign for each interval. X minus 4, the right interval will return plus sign for that factor, and minus sign for the middle, and the minus sign for the left side of the interval. Next factor, x minus x plus 1. The right intervals of the negative 1 will give you the positive sign or plus sign, and the left side of the point x equals negative 1 will return the sign of negative. So the product of both factors will be plus sign for the right interval, minus sign for the middle, and plus sign for the left interval. And we are looking for the product returns negative in sign. Oh, wrong one. Has to be positive. Next, find the domain of the following functions. The domain of the natural log. The function log is defined if the expression with the log is strictly greater than 0. So 9 minus x strictly greater than 0. Therefore, x is less than 9. Domain of this function is the interval negative infinity 9. Part B, f of x is natural log of x squared minus 3x minus 3x minus 4. This expression must be greater than 0. Factor completely x minus 4 times x plus 1 greater than 0. The product will be 0 at 4 or at x equals negative 1. Sketch the real number line, negative 1, 4, and analyze the plus minus sign for each factor. X minus 4. The value on the right side of x equals 4 will be positive. The left side will be negative. The value on the right side of x equals negative 1 will be positive. The left side will be negative. Then the sign of the product of these two factors will follow from the product of the two signs. So plus sign for the right interval, minus sign for the middle, and plus sign for the left interval. We are looking for the interval that return the product strictly greater than 0. Therefore, the domain of the function f is the interval negative infinity, negative 1, union the value 4, infinity interval. Sketch the graph of f of x equals log x minus 1 plus 2 and determine domain, range, x-intercept, and vertical asymptote. To determine the domain, x minus 1 must be strictly greater than 0. Therefore, the domain will be greater than 1. That provides us the vertical asymptote is x equals 1. The graph will appear on the right side of this vertical line x equals 1. The range is the set of all real numbers. The intercept. X-intercept occurs where y equals 0. So we're going to solve for x. 0 equals log of x minus 1 plus 2. This is the log base 10. So change log form into the exponential form. Before we do that, move 2 to the right to the left hand side by subtracting 2 both sides. So negative 2 equals log base 10 of x minus 1. And then changing log to exponential form. The left hand side is 10 to the negative second equals x minus 1. Return as x equals 1 plus 10 to the negative second is 0.01 or x equals 1.01. So the x-intercept is the order pair 1.01, 0. To suggest the graph, since the base b is 10, which is greater than 1, the graph is increasing. Let's find another order pair. If x equals 2, the y will be log base 10 of 2 minus 1 plus 2, or 2. So the order pair 2, 2 will be on this curve or the curve of the log function. Next, solve an equation using properties of log and exponential. not using the calculator. First one, 5 times 2 to the power 3 minus x equals 160. First of all, we are going to isolate the term involving x by itself. So we divide both sides by 5. So 2 to the power 3 minus x equals 32. And next, rewrite 32 as 2 to the 5th. Therefore, 3 minus x equals 5. Or x equals negative 2. Next example, e to the power negative 3x equals 10. We are using the natural log, apply natural log both sides of the equation. The left-hand side returns negative 3x. So negative 3x equals natural log 10. X equals negative natural log 10 divided by 3. Next example. Log of 64 base x equals 3 over 4. We are rewriting this log form into the exponential form. So 64 equals x to the power 3 over 4. To solve for x, we are going to raise both sides of the equation to the power 4 over 3. So 64 raised to the power 4 over 3 equals x. And 64 raised to the power 4 over 3 means the cube root of 64 raised to the power 4. The cube root of 64 is 4. So 4 to the 4th is 256. This example, we determine how much time is required for an investment to triple in value. If interest is earned at the rate of 5.75% compounded continuously, the formula for the compounded continuously problem is A equals P times E to the power RT. In this case, A as a future value is triple of the principal. R as the rate is 0.0575 as a decimal form of 5.75%. We are going to find T, or how much time that the future value will be triple of the principal value. So 3P equals P times E to the power 0.0575 times T. Solve for T. First of all, divide all by P. P and P cancel. We have 3 equals E to the 0.0575 T. Next, we take the natural log both sides of the equation. Natural log and exponential reduce or cancel. The right side becomes 0.0575 times T equals natural log T, 3. So then T equals natural log 3 divided by 0.0575, approximately equal to 19.1 years, to get the future value to be triple of the principal.